This question requires a very strong conceptual understanding of the wiring in an electrical appliance and what could possibly go wrong if the wiring is not done properly. So you are told that the kettle is plugged in and switched on, and immediately the fuse will blow. You're asked what could be the reason. The answer is C. Let's run through the options one by one. Now, if the earth wire is not connected, the appliance will still work because the live wire is connected, the neutral wire is connected, current is able to flow using the live wire into the circuitry in the kettle and exit the kettle via the neutral wire. So the kettle will still work properly. But there is a risk. The risk is that if there's any current leakage because the wires inside the kettle has frayed off and touches the metal casing, then it's going to be dangerous because there's no earth wire to direct the current that leaks out to the ground, and the person touching the kettle, the current can potentially just flow via the person to the ground, electrocuting the person. Option B, if I swap the live wire and neutral wire connections in the plug, now the kettle, most appliances without complex circuitry will still work. The kettle will still work because the kettle is essentially just a heating element within the kettle that when current passes through, it becomes hot and it heats up the water. So just visualize a typical circuit with a resistor, and I just take out the battery and swap the polarity of the battery. The resistor will still work because the current, even when it flows in the opposite direction, the resistor will still heat up. Okay, so the kettle will still work if we mess up the live wire and neutral wire connections in the plug. Therefore, B wouldn't cause the fuse to blow. Now, if the appliance have some diodes inside, some complex circuitry inside, then if we swap the live wire and neutral wire, the appliance might not work properly. But for appliances like kettle, it will still work. Now, when the live wire touches the metal case of the kettle, this means that when the current flows in via the live wire, the current doesn't flow through the heating element, but instead, because the live wire touches the kettle metal casing, the current will flow into the metal casing. And remember, in a kettle, the earth wire is connected to the casing. So this means that the electric current will go from the live wire into the kettle, and it goes onto the metal case, and then goes into the earth wire, and then go to the ground via the earth wire through the wall socket. There will be a current flows in this path. The current skips the heating element, the resistor of the kettle. Therefore, the kettle wouldn't work. In addition, because right now the current is short-circuited when it passes through the metal casing. The metal casing of the kettle has super low resistance compared to the heating element, so it's a short circuit. With the super low resistance of the metal casing, the current that will be drawn will be very, very high. This very high current, when it passes through the live wire, it will pass through the fuse, therefore breaking the fuse. And this is the reason why C is likely to be the fault that makes the fuse to blow immediately. Now, for option D, it couldn't be the reason, because if the wires are indeed very thin, then the resistance of the wire should be very high. Recall your resistance equation, R equals to rho L over A. When the resistance of the wire is very high, it means that the current drawn will be lower than usual, and a lower current wouldn't melt the fuse designed for the kettle.